Tonight we're taking a look at some other things that'll be on the final exam. This part of the final exam will be strictly pencil and paper. You'll be able to use your book and notes, but not the computer to verify the results. And for instance, this question would say, assuming that all the variables have been dimensioned properly, there might be a question saying, will there be a compile error, yes or no? If so, how would you fix it? Syntax error, compile error. So let's put that in the notes. Potential questions. Will there be any compile errors? And of course that would be the same as a syntax error. Will the compiler catch something? If so, how would you fix it? Will there be any runtime errors? I think I'll keep this singular. Will there be a compile error? Will there be a runtime error? If so, how would you fix it? I won't have more than one deliberately. But if you find more than one, go ahead and tell me, because I may have missed it. We'll say, what will results be? And that could be either output, data in a variable or variables at a particular point in time. Let's look at some of these questions and see how we are at predicting. After this first line executes, what will be in the variable int counter? After this one line executes, this first line of code, what is stored in int counter? That would be the number 1, right? When this line executes for the first time, what will be in int counter? 3. So what prints here? 3. Then what prints? What's the second thing that prints? 4. Yeah, then 5, then 6, then 7. And that should be in the output window. So I'm going to copy this code, go to our code window, do a new sub, and this will be sub test Q1, question 1. So I'm going to dim int counter as integer, put this code in here, and then we would want to indent our for next loop. So if we compile this, looks like no compile error, and if we run this, it does put 3, 4, 5, 6, 7, as we thought. Okay, now we're going to do question 2, which is a little different from this. Question 2, after this line of code, what's int counter? First line of code. 4. What happens on this line of code? What does int counter become? Should be 3. What prints first? 3. What does int counter become the next time it hits this line? 5. Increments by 2, step 2. So it should print 5, then 7, then quit. What will int counter be when the loop ends? After it finishes the loop and goes to the next statement, what will be in int counter?
Wouldn't it still be 7?
If it was still 7, it would go into the loop again. The next is what increments it by the step value. So it prints 7, then it says next, so it increments it to 9, then it checks and says 9 is not between 3 and 7, so it exits the loop. So when it exits the loop, there should be a 9 in int counter. Let's put it in and see. This is test question 2. If I left it test question 1, it should give me a compile error because I've got two subs that are named the same thing. I did a copy and paste. So now it should compile okay. And it does. Let's step through it, or at least let's stop it before it ends so we can see what's in int counter. So I'm going to put a breakpoint on the end sub. And now if I run it, we said we think it'll print 3, 5, and 7, and int counter should be 9 when it exits the loop. So 3, 5, and 7, it has exited the loop, and sure enough, int counter is equal to 9 at that point. Does this help clarify exactly what goes on in each line of code? I think that's the best way to learn programming, is to know exactly what each line of code does and what's happening in memory, what's going to be in each variable at each step.
Why did you stop it? Would it still?
Oh, excellent question. If I don't stop it, it runs. We have not talked about scope and lifespan of variables, so let's talk about that. The lifetime of a variable. When we dim a variable, you could think of it like this. The dim statement creates the memory location. The memory location was already there. It sets it aside and gives it a name, okay? But we could say creates the variable, which is a named location in memory. So you could say the dim statement is when the variable is born. It is alive as long as that procedure is running, that sub. When that procedure ends, the variable dies. Obviously, physically, there's a memory location there that still has something in it, but the program knows nothing about it. So the variable is born when we dim it. It's alive while the sub is running. It dies when the sub ends. This is a local variable. And by local variable, we mean the dim statement is within a sub-procedure. By local variable, we mean the variable is declared or dimmed within a sub-procedure. That's a local variable. Let's combine lifetime and scope. Scope says who knows about this? Who can access this? A local variable is declared within a sub, and it is only known, it's only known within that sub. So let's illustrate this. Here is int counter within sub Q2. Here's another int counter within sub Q1, test Q1. This is analogous to something with the same file name stored in two different folders. The computer does not confuse those, and in fact, those files could contain nothing alike. They just happen to have the same name. So document 1 could be stored in one folder. We fire up another new document and put something completely different in it, save it as document 1 in a different folder. That's the analogy. This int counter is completely different from that one. It's distinct, and this one is only known in here. This one is only known in here. We call this a local variable. There are also global variables. Global variables are declared outside of any sub-procedure, and everybody in that module has access to that variable. There's actually two levels of global. If we just declare it in this module, it's known in this module, it's alive as long as that module is in memory. Another module can access it, but it has to prefix it with the name of this module. Say, I want that module and that variable in that module. Anybody in this module can just use it with that name. Let's declare a module level variable. I'm going to say dim. I'll call it something different. These are all different from each other, even if we name them the same thing, because they're in different places. But I'll call this one int module, meaning it is declared at the module level. And notice that's in the general declaration section. It's not within a sub-procedure. I'm going to run this test Q1 again, and after the loop ends, I'm going to say load the number 18 into int module. Go find that memory location, load the number 18 into it. I'm going to put a breakpoint here. So when I run this, it prints my 3, 4, 5, 6, 7. What should int counter be right now? This int counter. It printed a 7. What happened when it hit the next after it printed the 7?
Probably 8.
Yes, it went to 8 because we didn't specify a step, so that means step is 1. So it went to 8, and then it said, oh, I don't need to do the loop again because that's not in the range. So int counter should be 8 right now. It is. Now this int counter is not even alive. It hadn't been born yet. This int counter has been born. It's alive, but when we finish running this sub, it will not exist anymore, at least not in an accessible form. Int module right now is 0 because it was declared, and when you declare it, it initializes it to 0 if it's a numeric variable. So it's 0 right now. Now I'll finish running the module. Actually, I'll just step one more time. Now it says that's 18. And this knows it's 18. When I finish running this sub, int module is actually still 18. So if I go in this other sub procedure and say print what's in int module right now, I'll run this sub. It puts our stuff in it. Int counter is 9. Int module is still 18. This is in a completely different sub, but because that was declared outside any sub, anybody can do stuff to it, and that's very dangerous. You want to keep your scope as small as possible. Always declare your variables within a sub. The only time you do this is when you absolutely have to, because a lot of sub procedures need to access the same thing. But always keep it as small as possible. Does that help? So this int module right now is still 18. I'm going to close the VBA window. The document is still alive. Let's see if int module still has 18 in it. No, it does not. I didn't think it would. As long as this is in memory, but when I closed that window, it flushed all that.